Hello everyone, welcome to video 2 of my instructional tutorials. In this video, I'll be showing you in detail how to ensure you have the best fit possible for my friction fit files, as well as some tips and how to properly assemble my products. So when cutting parts for the purpose of friction fit, cutting as accurately as possible is imperative. This means that any inaccuracies of over zero point zero 0.02 inches could be the difference between your piece connecting too loose or too tight. So I've had quite a bit of experience cutting friction fit parts, and in this video I'll share with you what I found to be some good practices. So as such, before we start, you'll definitely want to make sure that your CNC machine is square. Your machine positioning is calibrated and known. Your wasteboard surface is not badly worn. Belts, if you have any, V-wheels are tightened to proper specs, and that the tool you're using is worn from between good to excellent. There's some really good videos on YouTube on how to calibrate positioning and squaring your machine. In case you haven't checked them out, you should. I'm sure there's a high probability of finding a video that actually explains for your specific machine how to square it, how to calibrate, and whatnot. Another important item that I've experienced is not to remove too much material with a single pass. So my designs are all intended to use either 1/8 inch bit, or I've also used a lot a 1/4 inch compression bit. And I found that generally sticking to the rule of thumb of removing half the diameter of your bit, or in my case, I like to do slightly more than that, with each pass, it was a good rule of thumb for more accurate cuts. I should also mention that the better conditioned the bit, the more accurate your cuts, of course, will be. So just that as a little reminder. Also, I've noticed that using a better quality plywood with more layers provided more accurate cuts. So I highly suggest that as well. It's something like a birch plywood that has more layers I found worked really well. Okay, so now before we move on, to summarize, you've squared your machine, your positioning's been calibrated, you're using a good bit, you've decided on your depth of pass, any V-wheels you have or belts are nice and tight, and you've got a good quality plywood. So now let me take you through the process of making your cuts. To start, you'll want to be using 1/2 inch material for any garage organization piece that's on my page. And you'll have the option for using 1/2 inch or 3/4 inch for any other item on the page, such as the watch stand or the standing desk. I thought 3/4 inch was overkill for the garage organization items, so I only used the 1/2 inch. So the first thing you want to do, of course, pick your material and then measure its exact thickness with a set of calipers. Okay, so for example, your 1/2 inch plywood could be 0.475 inches, let's say. Okay. The next step, okay, and this is really important, I highly recommend it, and it's really the key to making the most accurate cuts possible. It's likely that every machine is going to have some amount of error in its cuts, okay? In particular with a lower cost hobbyist machine, which is what I was using and what I use. Even after calibrating and squaring it, it's likely your machine could be off a little, okay? So my way around that, if I switch screens, as you can see, is to cut a small test piece, okay? So I'm doing for example, a 4 inch by 2 inch rectangle here, and I've placed my tool bit inside the shape path, okay? And I've also done one where I clear out the pocket instead. So I've done one where I cut inside the shape path using tabs, and then this one where I actually clear out a pocket, okay? And then I use my calipers to measure the actual hole width and length, okay? So remember, I said that this was 4 inch by 2 inch, But when I actually measure how big that hole is, I might get a size of, say, 3.98 by 1.98. Okay, so basically 0.02 inches too small in both directions. So you can see how this would be a problem. If I go back to this screen, this would be a problem for friction fit, um, in that you'll want to account for this size so that you get this machine error so that you get the proper fit. Okay, so the way you're going to go around that, okay, is if you're getting 0.02 inch too small, okay, your hole, you'll want to select a file from my zip folder that is 0.02 inch thicker than your measured material thickness. Okay, so let me explain that. So for example, if I measure my material to be 0.475 inches, and I find that my machine is cutting widths that are 0.02 inches smaller than I intended, then I would simply download the file from my zipped folder, if I pull that up, okay, that is 0.495, okay? So that means it's 0.02 larger than my actual material thickness. So this will make the hole 0.02 inches larger than your material thickness, and hopefully that will help you account for that machine error. Okay. Now I do want to note that if I go back here, and I zoom in, okay, that all my designs, okay, you can see that there is a bit of space there. So all my designs are actually larger in width. All the holes here are slightly larger in width and length than the material thickness. Okay, so I found kind of the perfect size larger that it needs to be in order to get the right balance of durability and tightness while also being able to assemble and disassemble it easily. Okay, so I just wanted to make note of that the holes are already in the design slightly larger, but you do want to account for any machine error. Okay, so again, if your machine's cutting 0.02 inch smaller, then you want to download the file that is 0.02 inches larger than your material thickness. So the 0.475 material thickness that you have, you'll actually want to download the 0.495 inch material thickness. Okay. Now, even if you don't get the perfect fit, you do have options. For example, if I find my fit to be too tight, which was usually more so the case than being too loose for me, then I just run a rotary tool, something like a Dremel, around the perimeter of the friction fit components inside this hole. And I slowly run the Dremel inside there and slowly remove material, check for the fit, okay, as you go. If the fit's really loose, you can always shim these openings a little. I like to use, what I've used in the past is I've peeled off a thin piece of veneer from my waste material from my cuts, and I just kind of glue it into position anywhere there, and I found that really helped. So all is not lost if it's not a perfect fit from the start, but you can certainly minimize it by following all of kind of my best practices here. Next, I'd like to bring to your attention the fact that within each zip folder that you get when you download my product is an animation video. You can see it's here at the bottom, okay? And it shows you how to assemble and disassemble each respective piece, okay? So what you'll see is that each item has notches cut into them to show you how each piece should be oriented when assembling, okay? So if I take you here, as you can see, zoom out here, In this case, I've put a little notch here on the right, a little notch here, and if I orbit around, you can see that this piece also has a notch here. So they all line up, these notches, just so that you know how everything should be oriented when you're putting it together. Okay, so in this case, the notches should line up on the right. So be sure to look for those notches in the animation video in order to assemble in the correct orientation. Okay. Now, the last thing I want to do in this video is show you the process of importing the DXF file into your CNC software. You can see here I'm using easel, but I mean the same would apply, the same concept applies for whatever you're using, whether it's VCarve or whatever else. So let's use the example that we said earlier. So let's say my machine error is 0.02 inches and I'm on the small side, and my material is 0.475 inches thick. I'm going to import the 0.495 inch file into my software. Okay, so I'm just going to go to import, and I'll just show you quickly. Look for the 0.495. Okay, and you can see it come up there. It's going to change the generic cut path right now to outside, but more on that in a second. Okay, I'm just going to remove my, and you can see, okay, I'm going, so once you're in, all the components will appear, okay? Based on the size of your CNC machine, you can cut and paste them into different cut files if they can't all fit in one. So you can see I'm using a 24 inch by 24 inch sheet. So I'm simply just going to take these pieces, cut them, and paste them onto a separate sheet while keeping these here, okay? You can spread these out how you like, okay? So obviously orient it any way that you need to, okay? Spread them out. There's one important thing I want you to make sure is that for the outside of your components, be sure that your tool bit is cutting on the outside of the path. Remember, everything needs to fit just right. So make sure that, for this component, for example, everything is cutting on the outside of the shape path. For this component as well, everything on the outside. This piece here, again, the perimeter I want to be outside shape path, but these holes, make sure, okay, these holes, you want them to be either inside shape path or clearing out a pocket, okay? I like to usually, if I'm using my 1/4 inch bit, I just like to clear out that pocket, okay? So again, remember that any outside shape, make sure that your tool bit is on the outside of the path. And any inside hole component, make sure that you are either clearing out a pocket or your tool bit is inside the path. If it's inside the path, make sure you're putting, if you need to put tabs there, put one tab. That's what I found works best. It holds pretty well. Okay, so hopefully this was a good instructional tool for you. And thank you for purchasing my product.